This is the story of how we slayed a sea monster. Not the kind of story from old sailor legends, but a very real challenge looking at our modern oceans. We faced the unknown in forms of gaps, assumptions, and interpolated data on our nautical charts. In Danish waters, more than 71% of data is actually interpolated. And this is where MobiSpaces use case 5, CrowdSeaMapping, comes in. Hydrographic surveys are conducted to make sure areas are safe for navigation. But at the current pace, and with current technologies, it would take more than 100 years to fully survey all of these waters. Some of the data we rely on is more than 150 years old. Brave souls sail these waters every day, and each vessel is equipped with global navigation satellite systems and echo sounders if they're big enough. All of this data is only used for navigation, but if it was somehow recorded and shared, we might use it to chart the unknown waters. So, we built a box. It's autonomous, meaning no interaction from the mariner is required. It's able to work offline, interfacing with the ship's network of sensors, recording everything in real time. Then, when they're shore again, close enough to a 4G network, it will synchronize all of the collected data to a central server. In the summer of 2023, we tested the system for the first time. For 37 days, the system performed flawlessly aboard the Dana. This was the first test of a crowdsourced bathymetry data logger by the Danish Geodata Agency, and it proved immediately useful by becoming a tiebreaker between two conflicting data sets, ensuring that the sea north of Hirtshals is deeper than initially thought. We had our second real-world test less than a year later in the spring of 2024. This test lasted for almost a year, collecting millions of data points for more than 300 consecutive days. This proved that the system is very robust and able to recover after a power outage. The data is not perfect, however. Bubbles confuse the echo sounder, and sometimes sound waves bounces back and forth between the keel and the sea floor, creating a double false bottom. Even the motion of the ship in the waves affects our measurements, so our expert hydrographer marked each of the more than 1.7 million data points either accepted or rejected, after accounting for tides, of course. While we might be able to scale up to 1,000 CSP boxes aboard 1,000 ships, we cannot hire 1,000 hydrographic experts. However, we can build an anomaly detection model using machine learning to do all the hard work for us. So, that's what AIT did. Not only that, but the MapFed model, as we call it, can run in a federated setup. That way, each ship in the crowd has its own model that is improved in real time and works decentralized. The two major benefits to this are, firstly, only the MapFed model is transmitted to the central server, not the raw data. This saves a lot of bandwidth. Secondly, since no raw data is sent, the exact data is not shared directly, increasing privacy for the crowd participants. When compared to a human, the model performs exceptionally well, with an accuracy of 85% of anomalies being detected, depending on the exact model and test area chosen. The system was also integrated into the MobiSpaces common front-end, where the anomaly detection module can be accessed via a user-friendly dashboard. With more than 70,000 ships sailing within Danish waters each year, imagine how fast we could map the seafloor if just a fraction of these ships had a data logger installed. Oh, remember that initial test? Yeah, the data from that trip was used in the second version of the Danish staff model. It's the first time crowdsourced bathymetry data has been used in any official Danish Geodata Agency product.